to refactoring again. So refactoring, as I said, is this idea of making improvements to the program to slow down that degradation that happens through change. So if all we do when we're changing the program is put a little patch here and a little patch there and a little patch there, it starts looking like a patchwork blanket. Okay? And you might like the look of a patchwork blanket, but when it comes to software maintenance, it's not a good thing because it's very difficult to see the overall structure of the program when you start getting those patches everywhere. So we use this idea of refactoring to, after changes, just reconsider the system as a whole and work out if, okay, so we've fixed that thing, but can we actually clean up the way that we fixed it so that we keep a nice clean structure somehow? And it might involve changing the structure that you had in the first place because, you know, the security was caused by the structure that you had originally or something like that, security flaw, I should say. So yes, it's an extra cost when you do a bug fix or something like that. So it means that you're not just fixing the bug, but you're actually thinking about the overall structure. But you should think of it as a preventative maintenance that's going to cost you a little bit more now, but in the long run is probably going to save you. Right? So it's a forward-thinking way of doing software maintenance. Your aim isn't to add functionality when you're doing refactoring, it's simply to make the structure better. Okay? So easier to maintain. You might even be looking at performance optimizations. Okay, so how can we get things to go faster, bigger, whatever. And it should be a continuous process throughout the maintenance and evolution process. It should, if you do refactoring well through that maintenance process, re-engineering can largely be avoided, right? Because you keep something of high quality. Remember, we talked about this idea of high quality, high business impact being something that you would just maintain, right? So if we can do this small cost of doing refactoring along the way, then hopefully we'll stay in that position. Okay. So in summary, just before the fire alarm, testing can only show the presence of errors in the program, and it can't demonstrate that there are no faults. Okay. Only in the really most simple cases where you have a really limited number of inputs can you show that there are no faults. For any business process type software, you can't say that there are no faults. Testing is involved in both verification, so looking at the correctness of behavior, and validation, which is the correctness of the product. And there are lots of different types of that testing, focusing on different levels of testing, right? And the full testing process includes them all. Software development and integration, and evolution is an integrated, iterative process. You can look at it as a spiral model, but it's really easier just to say it's a circular model, where you're going backwards, right, round the loop continuously until the software is retired and no longer in use. Okay? And it's often cheaper and less risky to maintain a legacy system than to develop a replacement system using modern technology. But only if the quality of the legacy system is maintained as well. Right. Fire alarm's due any second now. So I'll give you a 5-minute break, and then we'll go to the discussion questions. Speaking of discussion questions, so there was a relatively low number who submitted them this week, well, last week I should say. I'm guessing that's because you did well in your previous weeks and you figured you had your 6 times Bible near enough to it already. But in the case that it was that you really found it difficult, I did put up a solution to that set of problems in that week's area, so you can have a look if you want. our tests and we get no faults, that just means that for the things that we've tested, for the particular circumstance in which we've tested them, things work the way they're meant to. However, if there was some slight change, we can't guarantee that that is going to also not give an error. You know, it could be just one little thing change, and it might not be about the inputs, it might be about the amount of data that's been stored in the program so far. You know, like if it has a buffer overflow, we can't guarantee it. So even with the same set of inputs, at a later time, you might get an error. Okay? All we know is that at the time we tested it with those particular inputs, there is no problem. We're not guaranteeing anything about the complete universe of the things that could happen with this program, because we can't, right? Okay, the next one is about regression testing. Okay, so first of all, what is regression testing? And then, given what it is, how can automated tests and a testing framework like JUnit, which I know you don't know yet, but just it's a thing for running automated tests, explain how it simplifies regression testing. So what is regression testing?
It means that we have to, when we make a change, we have to test everything that we tested before that change also to make sure that that change didn't affect anything before.
Great, exactly, that's what regression testing is. The idea that when you make a change to the program, you have to test everything that you tested before it as well to make sure that what you think is an isolated change doesn't have unexpected consequences on other parts of the program. So how does automated tests and a testing framework help with this?
If we make unit tests as we go along the way, we can run them automatically after we make some change to check if every component works as it worked before.
Yeah, so you build up a bank of all the tests that you're doing, and every time you make a change, all you have to do is press one button and it just runs all those tests again, exactly as it ran them before, right? So you know that you're doing the same testing every time, right? And you're testing all those previous things that you were testing before. If you do things manually, you have to be really careful about noting down exactly what you've tested each time and writing down sort of a list of things so that when you go back to test them again, you have that exact same input that you had before. And well, not only is it a lot more painful because you're having to type everything in, but you're also having to check that you have done absolutely everything. But just being able to press a button is a distinct advantage. Okay, so we talked about this idea that when you have a high quality and high business value legacy system, that usually the best approach is to maintain the software that you've got. But can you think of a situation where the organization might decide to scrap the system despite this assessment? There's more than one answer to this. Yeah.
The system has a lot of faults and is not.
Yeah, but we have said that it's high quality, so it's not going to have lots of faults.
The updated version or updated technology can change the business in a different way so that they can get more profit, much more profit.
Yeah, so that's a good one. So yeah, so it's working really well for the business at the moment, but actually if they take advantage of this new technology that becomes available, they have the opportunity to do something significantly more than what they're doing at the moment. That would be a good argument for it.
And if the companies they are working with already changed the working platforms or software,
Yeah, so if they've got this software, and particularly if this software has high maintenance costs, and they're going to have to make changes to support new hardware or something like that, then redesigning the software from the whole when they're redesigning it for the new hardware, so rather than just porting it to the new hardware, if they actually go through a redesign process there, the cost-benefit analysis might work out. That's a good one. Anything else? It might be just that there's no longer any support for the tools or languages that are used in that system anymore, right? So not only is the software obsolete or using obsolete technologies, but the obsolete technologies that it's using themselves become outdated and buggy, and there's nobody fixing them. Okay, so if that's the case, that's a pretty clear indication that even if the software itself is of high quality, the tools supporting it are degrading. It's time to look at developing it so that we can use new supported tools. Right? Because if say the compiler, you have to use an old version of the compiler which itself has bugs, that's pretty risky, okay? Because the compiler having bugs might introduce bugs into the generated code which you have no control over. Okay, so you managed to pick 2 of the 3 ideas that I had. As I said, there's probably more than the 3. But yeah, well done for picking those 2. So yeah, even when you've got this high quality software of high business value, there still could be reasons why you might choose to replace it with something completely new. Okay? And it's all about doing cost-benefit analysis, and it's a difficult thing, particularly for this type of system, because, as I said, it's not just about the software, it's about everything around it in the business. Okay. That's really got discussion questions for this week. You've got your reflective report. I've spoken to at least a couple of people about the feedback on their reflective report, and if any of you want to discuss your feedback with me or have any questions about it, I'm very happy. I've got some office hours available. Just email me and I'll send you a link to book. I'll be seeing you again next semester for the practical application of all this knowledge. Okay. Hopefully then that will sort of consolidate why we're doing all these sorts of things. But again, it's in a constrained setting, okay? So we're only looking at going from the requirements analysis through to deployment, and it's not all this phase, which, as you saw, is the largest part of software budgets in large organizations, right? So it's only part of the software engineering process that we're going to put into practice. And realistically, in a modularized university degree, you can't do that entire development process. Okay, you're only here for a year anyway, but even for the students in a 3 or 4 year degree who are here, because all of the modules are separate, they're kind of like, they do either 1 or 2 semester module on software engineering process, but then that's the end of it. Okay. So you can only learn a bit of it in a degree, in the practical side of things. The students who did the supplementary questions for the first few weeks, I apologise for not having marked them yet, but I am aiming to get them done by the end of this week, along with your discussion questions that you submitted yesterday. It's just been the master's project allocation is a very big task. There are a lot of you this year. We only had about 100